Okay, so let me explain what actually this project is about. The project from the Solidity Zero Knowledge Bootcamp from the NCOP company. So we had the weekly project to create the full stack application. Here is the task, you can read about that. But in short, we should create the two websites. The first, well, actually the full stack application that consists of front-end and backend. Also, we should provide the specific smart contract written on the Solidity language on the Ethereum chain. And it should be combined in one application. So how to achieve this? First of all, we have the open source repository, Zero Knowledge Solidity Army. You can go there and fork anything, for example, the week 4 lesson. So it's here and here. Here is the front and back end. Also, it's already deployed, but I will explain in the local hosted version, just to understand how it works. So let's go here to the Notion and find the information about that. So this is the voting dAPP, decentralized application, to make ability of users to have the votes power on the blockchain. So why should we use this? For example, we need to vote for a specific, event, and we should, secure the ability to not vote for users that not have the voting power, to delegate this vote power to other users, etc., etc. So let's go to the code, and I will show a little bit of construction of this. So here is the code itself, the back and front. Let's go to the front. First of all, we start with the front end. The front end has the scaffold fork. What does the scaffold mean? If you go here and, well, actually I have this in my repo. This is absolutely amazing, fantastic template to start with, made by the scaffold team. This is absolutely a public template. You can fork this, use template. What is this about? It allows you to have the user interface from the out of the box. So the main reason to use this is to economize of your time. What it provides, first of all, you should be careful to use only the yarn of the second version. It's somewhere it is written, I think. Yeah. V2 plus. This is super important. Don't use the npm. Don't use the version 1. If you don't know how to use this, go to Google this yarn v2 client, install this. Core pack. You should enable core pack because it allows you to change the versions of the yarn as a package manager, right? So you can check this by going to the PowerShell or whatever you use, for example, command lines, Git, you can work there, PowerShell, etc., etc. So there are a lot of them. And let's check this. Yarn version. So we have the second version plus, right? All is good. If you don't have this, first of all, you need to follow this. Second thing is, yeah, let's go to the code back. So we have the front end. It consists of the packages. In the packages, we have the two actually super big parts. First of all, it is the Next.js. This is like a library as a React. It's more powerful. Not the more powerful. It solve other problems. For example, it has the server-side rendering. It has the pretty optimized speed of performance, blah, blah, blah. So here we have the application. It's a little bit modification of that scaffold template, of course, because we created for ourselves. And the initial point of the application is the page TSX. TSX, it's mean like a GSX, so it's JavaScript for a compilation to the HTML after the compiling period, but it is the modification of the GSX. So this is the same as TS, for example, TypeScript file, but X means that it will be compiled into the normal HTML language, right? So in this way, you can work with the normal tags of the HTML tags. It's not a problem here. Also, you see the components here. So we sorted this by the architecture purposes to the components, of course. Okay, so this is about the application. The second important thing is the hardhead. Hardhead, it's like a it's library. It's library that allows you to open your. Well, it allows you to interact with the blockchain, and also it can be used by creating your own blockchain on the local machine to not pay, real money, to test some things, to scrape information from the real smart contracts, etc., etc. And here we have the scripts, the tests, and the contracts. The contracts, of course, it is the same things that you see on the header scan. What does it mean? For example, you have the normal header scan is like a big database of the different smart contracts. So, for example, you can go here and find any smart contract. Here is the smart contract. You can see the contract itself. Yeah, it is not verified. Let me find any verified versions. I'm not sure that we'll find it here. Maybe it will be in the trending ones. Well, actually, we can find any on the DEX tools, on the DEX exchanges. So I'll be fast in a moment. Well, actually, let's follow this together, okay? They changed a little bit the UI. I need to find this. So it's like, okay, DEX scan, tokens, trending, something like that, maybe. Yeah, let's go to the coin market cap. And for example, let's say cryptocurrencies on the Ethereum chain. On the Ethereum chain, it will be, okay, CryptoCat, whatever. Let's find the contract. Contract itself is here. Okay, CC8. This is the wrapped Ethereum. This is token itself. Let's go actually to the header scan. Yeah, this header scan. You see the contract is verified, and finally we found the initial code. So this is the program. This is Solidity program that can be launched, that you can interact with this, you can write, you can read the functions. It is internal and external, of course. Different. You need to pay the gas to have the write contract. You don't need to pay the gas on the read contract. It consists of the API. This is JSON file that allows developers to understand the functions that are in the in the contract itself. And well, as you see here, for example, we have the license, right? The pregnant solidity version and the contract itself. It's something a little bit glitching. So this is a big file, okay. So the same, let's go here. And the same idea is here. So we have the license, we have solidity version and the contract itself. We separated the different contracts. One contract is about the tokens itself, because you need the tokens to vote, right? Because, well, how you will vote? You need to pay. You need to say that I want to vote for this, person, or for this proposal. Okay, the potato, and I want to vote for one or maybe 20 scores or 20 tokens. I want to put the 20 tokens to vote for this proposal. Of course, we can limit this. For example, one person, one vote, and that's all. But for development uses for the weekly project, we need to focus on the larger scope. So this is about the token. Here's the NFT. It's I'm not sure that we use it actually here. I'm not sure about that. Let me see it. Maybe it's here. No, we are not using this. Okay, so my token. Okay, so to pay this tokenized ballot, it's about to. Yeah, this is the logic of the voting power. So it has the ability to limit your votes. So, for example, if you don't have the ability to vote, you will revert this transaction. You don't. We don't want this. We prevent this, of course. So this is about the contracts. This is some scripts to run this. Test doesn't make sense for us right now. And okay, and after this we started the backend, separated the tasks between the developers. So I was working on the front-end part. Let me actually launch this. So let's go and find this. Yeah, so this is here. Let's check if it launched. It's compiling. What does it mean in compiling? That there is 6 files into the normal HTML pages. Okay, so we are here. And we see that we don't have anything, but so we have the function to delegate a vote, for example, to another wallet address, to maybe ourselves, to delegate the votes. We can mint tokens to vote, because we need to pass here how much tokens we want to vote for a proposal. Here we see that we have no Ethereum, sepolia Ethereum tokens, and we don't have the tokens to vote, right? Let's try this with another account that I have. Let's go with this one. So, for example, here we have the balance, right? We have the tokens balance. Let's mint more. Let's say 10 more. And this starts, well, actually this goes to the backend first. This is the backend, and it has a lot of endpoints. So we're requesting this to the backend, and from the backend, we can sign the transaction by providing key from this wallet address, and we can check this. It's 0x8a. Let's copy this actually. We can check this on the scan, on the sepolia scan, and we should see. Sorry. It's coming from the contract and minting tokens for our wallet address. So we need to find the contract. I will show you. It is in the environment. Of course, I will show you right now. It's somewhere, I think, in the front end, maybe. Yes, I think I found this. Yeah, so this is the contract. It is, of course, on the backend, because we requested this API to the backend. So actually, we can check this. To the network, let's mint for about maybe 50 tokens. Let's go. We ping this API endpoint. Let's check this my token mint tokens. This is the get request. Mint tokens. Okay, let's say mint tokens. Yeah. The post. Okay, the post. And we provided, this is example, we provided two specific address that we have in the environment variables of the backend, and amount. Amount is 50. We can check this here. Okay. 50 and the address and the amount. Okay, so let's go here, and after that it sign the transaction from the, not from this wallet, but from the wallet from the contract that we created. So we have here the transaction, 50 tokens. We can check this in the logs. Why it says like that? Because it is in the specific format of the tokens. We can calculate this like F to way calculation. Let's go convert this, and it is 50 amount of Ether, not the Ethereum. This is the just formatting of the tokens. So let's go back here, and we found this in the token balance that it is updated. Okay, we have the transaction hashes. We can, for example, go to the other scan by clicking this, and find this information here. Again, we can find the amount here, we can find the amount here, or we can find in the logs. This is absolutely the same situation. After that, we have the balance. We have the balance to pay the gas price. We can delegate the vote power, let's say for ourselves. I don't know, maybe we have, maybe we don't have this vote power. I'm not sure, but maybe we can check if we have the ability. No, we can't. Okay, so let's copy this address, our address, delegate the vote power. Again, it goes to the endpoint here. Let's sign this. I'm not sure what actually endpoint, but I might have rejected the role. Okay, so we created this, we delegated the role, and finally we can work here. So we can choose the proposal. We can enter amount to vote. We didn't finish actually this because for all this application we should have finished this application for about in 3 days. In 3 days we should create this. so it will not work, but I want to show the endpoint. No, okay. It doesn't matter, okay. And after that, you vote this, and it will recalculate the proposal. So that's it. I didn't show you the backend code. You'll find this on the GitHub anyway. So in the backend, it is very important to set this environment. It's like example. In the environment, you'll see the real information. Do not use in production the example files, because it should not be exposed anywhere, but you should use in the env. So in the source we have the entry point of the backend. Here we created the port where we should start this. After that we have services and DTOs and the controllers, of course. So how it works? It works like that. In the application, in the controllers, you can write what you willing to show on the Swagger website. So it means here. So all this getter or post. So for example, we have here the get, the post. So it's sorted here. You can create only one controller files, but it's only about the architecture style. In details, you can find the information about the what address you have in the variables, and the services is about how these endpoints should interact with the front end, for example. So it means what you want from them to have the logic on them. So for example, here we are saying that we should use the gas used as a result, as a response. We should calculate the cumulative gas used, etc., etc. So this is about the logic. In the services, you have the logic. In the controls, you have the entities of the get, post, delete endpoints, and in the details, it's like a configurational file for the backend. Something like that. Stay tuned.